SARS CoV-2 infection triggers mechanisms that cause Parkinson's disease. In a recent study published on the bioRxiv preprint server, researchers demonstrated the impact of an amyloidogenic severe acute respiratory syndrome coronavirus 2, SARS CoV-2, protein fragment named SK9, on synuclein, as monomers and fibrils, a possible risk factor for Parkinson's disease. The effects of an amyloidogenic SARS CoV-2 protein fragment on synuclein monomers and fibrils, according to a study. Several studies have connected SARS CoV-2 to an increased risk of Parkinson's disease and other neurological illnesses. Following COVID-19, a potential mechanism of Parkinson's disease is SARS CoV-2-mediated amyloid production as aggregates of As. By interacting with amyloidogenic regions on the nucleocapsid, N, envelope, E, and spike, S, proteins, SARS CoV-2 may have accelerated as amyloid formation in vitro. However, little is known about the SARS CoV-2 infection, the emergence of fibrils, or the symptoms that occur. The researchers looked at how the SARS CoV-2 remnant fragment SK9, found on the E protein's C terminus, interacts with the conformational ensemble of As monomers and the stability of two resolved fibril polymorphs known as the rod and twister structures. A helix-rich model of the As monomer structure was resolved and stored in the Protein Data Bank, PDB, under the identification code :1XQ8 using nuclear magnetic resonance, NMR, solution in the micellar environment. Decamers with 5 layers and 2 protofilaments were created using cryogenic electron microscopy, cryo-EM, structures to test the stability of the As fibrils rod and twister polymorphs. In C, for the rod, PDBI D, 6Q7, polymorph and D, for the twister, PDBID, 6Q8, polymorph, cryo-EM structures of the fibrils' initial conformation are shown. The fibrils' corresponding structures are shown in E and F, with the individual chains extended to residues 38 to 120. The findings reveal that, despite having a bend-arch structure, the rod and twister polymorphs' interprotofilament interactions are distinct. This suggests that SK9 binding exposes more hydrophobic residues in As, changing the ensemble towards more aggregation-prone conformations and modifying the generation of As amyloid monomers. The interaction with SK9 increases As ensembling selectivity and rod-like fibril seeding conformations by inducing increased flexibility, residue exposure, and a lower helix propensity, particularly in the section E46A56 that occurs in the rod fibril polymorph during the interprotofilament interface. The stability of newly manufactured or previously created rod and twister fibrils is unaffected by SK9. Simulations utilizing A, the twister-like synuclein fibril model, PDBI-D, 6Q8, determined empirically, and B, the enlarged model produced typical final configurations. Corresponding final snapshots extracted from simulations in the presence of SK9 segment are shown in B and D. For the extended model configurations in C and D, only residues 43 to 83 are shown. D. The shift in frequency within rod and twister fibrils will modify the risk of acquiring Parkinson's disease, according to the research, because mutations in As that disrupt rod fibril stability have been associated to Parkinson's disease. This inference is critical because SARS CoV-2 SK9 enhances the possibility of creating rod polymorph during COVID-19. According to the findings, the inclusion of SK9 shifts the ensemble of As to more aggregation-prone conformations. Even though the twister fibril was more cytotoxic, the interaction of SK9 resulted in a preference for As monomer conformations, which presumably seed the rod-like fibrils connected to Parkinson's disease risk. To test if this effect is limited to SK9, more simulations with other amyloidogenic areas of SARS CoV-2 proteins, specifically in the As, are needed. Furthermore, the interaction of SK9 with the rod and twister fibril polymorphs had only a little effect on their stability, according to the research.
Thank you for watching. Hope you will like the video I created for you. Please support me, click on subscribe. Then click on the bell. Please tap the below to view videos of the same series.